welcome for the second session. Now we're gonna be listening to Chris. Chris has been working with Paycor for 5 years. Okay, he's an expert in data management cloud and with HR data, human resources data. So it's a pleasure to have Chris Eldredge talking to us today. And so we're gonna have a 40-minute discussion and then 10-minute Q&A at the end. Okay, thanks, Chris. Yeah. Thanks a lot.
Good morning, everybody. Great to see everyone here at the Symposium. I'm Chris Eldredge, and we're going to talk about how to exchange data. So let's tell you a little bit about me first of all. So I built the data office at Paycor. When I showed up in 2019, Paycor, they did not have a data office. They did not have a data warehouse. They did not have a cloud data platform. Today we have a very advanced cloud data platform with high velocity data ingestion using Informatica tools, as well as a very robust Snowflake cloud data platform, which we use for data warehousing, for all of our foundation for our customer-facing products, and we also use it for operational processes as well. I've been doing this for a long time. I remember it wasn't quite as far back as what he was doing with the statistics back in 1985. I wasn't being paid anything back then, but I did learn statistics on an old computer with 5 1/4 floppies. I also worked at SAP, so I have a lot of experience with logistics and data and analytics from the ERP and enterprise software space. And I've been an independent consultant for a long time as well. I've worked with over 20 companies around data strategy, data governance, business intelligence, and data warehousing. A little bit about Paycor. Paycor is a human capital management software as a service company. That means they are an HR software company. We do payroll, time, talent, and some other activities that your human resources staff would do. There are about 3,000 associates at Paycor. We have, almost 31,000 customers, and the big number is there's 2.7 million people that are on the platform. That means the majority of those, not all, are getting paid by Paycor each week, month, or every year, depending on who you pay. And Paycor is currently a $655 million revenue company, which makes us not huge, but not small. All right, so we're going to talk about data interoperability. So who shares data? Data can be shared across teams within companies, across departments, across organizations, and even across systems. And just to make sure we level set what we're talking about today, we're talking about data sources, which is one or more data tables. It's going to have some standardized information related to names and types and whatnot. And we're exchanging that data in some way, right? So there's going to be a data target. There's usually many, many data targets. And we want to make sure what we're talking about is how do we make sure that we're going from a source to a target, and most of you are going to be consuming this data using targets, that we make sure that we have something that's stable, consistent, and works really well. So some of the considerations we want to think about is who owns the content? How complicated are the data sets that we're pulling from? We want to think about the breadth of metrics. How many metrics are we getting, and how do they fit together? We want to think about when does the data change? One of the big problems, is anybody here a practicing data engineer? Okay, a couple. One of the biggest problems that you get is data changes, and how you handle those data changes can cause disruption, cause issues, cause all sorts of problems. And we'll talk a little bit about that. And then the number of consumers of your data source can make a huge difference in how you think about packaging that data so they can consume. So let's start talking about the ownership. A lot of times, the people that are the experts, the owners of the data, aren't data engineers. They aren't data scientists, but they are people that have a domain expertise in a certain area and understand how that data should be structured and how it works. So we need to think about who these people are and make sure that they're always named, right? I manage a data platform, but that doesn't mean I know everything there is to know about, say, payroll data. There are experts at Paycor that know how to do that. They do it every day. But what they don't know is they don't know how to send that data for high-value consumption and consistency. We also need to think about calculation methodology and rules, right? And so that's something where it's going to be really important. I'm going to give you some examples where that can vary. Next, let's talk about complexity. So field names and data types. I got really excited in the last session when I started seeing that ... type that he said he didn't know what it was. I knew what it is. And that's really what we're talking about is how is that data structured? We had a problem at Paycor not too long ago where we took a data type which was a varchar from 50 to 250. And people didn't realize that they had a bunch of data consumers that had also modeled their field at 50. And so when we started putting descriptions in of 51 characters, we got a lot of work orders. Things broke, right? And so that's what we're really talking about is you have to match what the source data looks like to the target data, what it looks like. And if you don't do that, you can break a lot of things with very simple things like adding one letter. We want to think about the update frequency. I have data sets that update every 10 minutes. That's as close to real time and in a lot of big data areas that you're going to want. Real time is tricky and expensive. Anybody work with data sets in real time? Yeah, you know how expensive that is.
Yeah.
Your intended use cases. It's really important to think about how are people going to use this data. That makes a giant difference in terms of how you want to structure the data. What kind of calculations and permutations are your consumers going to do? That's going to make a difference. How they're going to aggregate the data and the grain of the data. Anybody know what a hierarchy is? Hierarchy up and down the chain. Well, a lot of times you have different data sets at one level of the hierarchy mixed with something from a different level of hierarchy, and then the data doesn't fit. And the last thing is, there was a question this morning in the keynote about how do you know the source of the truth? When it comes to data, you don't, but you do know reconciliation, right? So what should the data tie out to? What should it match to? And that's how you figure out if the data is correct. How many metrics you have? This is really where we're going to get into the heart of some of the game changers that we got in this session today. How many metrics? If you have a lot of different metrics, right, it's really difficult to keep them all in sync. And so that's what we're going to talk about. The other thing is how you group them and how quickly you add new metrics make big differences in terms of what you do. I talked about the data changes, and that can cause a lot of disruption. Most of your IT work today is not work, it's rework. And that is a lot of times caused by changes in the data or the source availability of that data. And so we need to think about that. We also need to think about, are we constantly having process changes, right? Are we adding products? Are we changing the way that our salespeople are organized? Those are all things that make a difference in terms of how people want data. And then when data does change, how you handle it. If you work in finance, there's a concept of restatement where you actually have to go through a whole process to say, hey, I'm going to take these numbers I previously published, and now I'm going to tell you that I've changed what I previously published. And that can be painful. So you have to think about how you're going to handle that. And the last thing is, if you have a data set that's used by a significant number of consumers, that's going to change the way that you can think about versioning or changing what you're offering. You know, if you want to add a metric, and you know that adding a metric might cause instability with some of those end users, you might really have to think about how you're going to do that. Okay, so let's talk about what is data exchange, and this is a very simple example. ELT stands for extract, load, transform, meaning I'm not making any transformations in my data exchange. I'm just going one to one. And in this example, we've got some sales for Ohio. We had 500 transactions, and that resulted in $14,000 in sales. I'm literally just moving from A to B. But again, what we talked about is that receiver structure has to have the equivalent fields and data types to be able to catch that. If my sales data type here was a binary value, and I send over $14,000, it's going to break. talk about ETL. ETL, then extract, transform, load, which is the old way a lot of people did things. You're actually changing the data in flight, right? And so in this case, we're creating an average sales metric. We're changing that data, so we're not having a receiver field called sales anymore. We have something called average sales, but we still have to think about the data types and the inputs and outputs to make sure they match. And this can get very, very complicated. If you have a lot of sources and a lot of targets, and the targets require consuming a lot of sources, you can see very rapidly that even on a small scale, you can have a lot of complexity go into your data exchange, right? And if I change any one of these sources at the top, there's quite a few targets that are also impacted. So one of the things that we're doing now at Paycor and in other places I work is we're actually changing the way that we structure this data to make it easy for consumption. And the way we're doing that is instead of basically adding a column every time and making everybody have to do all that rework downstream, we can actually add the metrics in terms of a row-based approach, so that I could come up with a more lightweight, generic way to actually stage the source data. And then I can, if I add a metric to this, so if I add metric 4, then I could just add it right into this mechanism, and then all the downstream pieces, parts that are there don't have to change. Seems very simple, but this is a little bit complicated for the data engineer. So now I've learned that painful things you remember more. So I'm giving you an example of last week's Bengals game. Anybody feel the pain of that? So here's some data that we can pull out of that. You know, basically we had a game, Ravens and Bengals. We have a date of when that game was. We have a start time, and then we have the points for the Ravens, boo. Points for the Bengals, yay. But they didn't. That's a data set. And if I'm going to change this data set, there's some problems with this data set. What are some of the problems? Well, if I go and add the next game, I'm adding to the pain with the Chiefs game for you guys. If you go to the next game, now we have some problems with our data set, right? I'm looking at Ravens points. Well, Ravens didn't play at the Saints-Chiefs game, right? So I can't have that column called that anymore. I just broke everybody's data. Same with the Bengals. Also, I added a field. I said, oh yeah, the Bengals game went to overtime, but this one didn't, and people are going to want to know that. So I've just added a column. This, again, is causing a whole lot of work for people downstream. So with our new approach, what we can do is we can actually create a more generic framework to structure the data. And this allows us to put all this data together in some consistent ways. We can actually create a generic team and opponent. We can create a metric that has a bunch of data in there, and we can create the values. And in this case, if you want to look at this, you can say, okay, the Bengals played the Ravens, that was their opponent, and there's one game, and there's some points for. We can do the same thing, Ravens played the Bengals, and they're one game and points for against in overtime. If we do that, what we probably want to do is we probably want to make it a little bit easier for the consumption of this data, since now I've put a bunch of embedded data into one data set. Probably want to make numeric codes. Systems especially like numeric codes, not regular English codes. Because what if you're multilingual for that matter? But numbers are easier when you have systematic data exchanges. And so we want to add these in here. This is going to help us to make sure that we have the right metric, looking at the number, as well as make it easier for systems to consume. And so if we do that, you can add in this metric number, and then if I'm a consumer, and all I care about is I want to count, how many points did every team get, I can pull that out, that number, in that case points for is 1001, and I'll get just the appropriate rows for that. So let's talk about the grain for a second. We talked about hierarchies, and we talked about how to think about what grain of data that is. So we were looking at one game at a time, right? But if you look at the NFL schedule, NFL groups games by the schedule week. In this case, it's week 5. right? And week 5, as you can see, actually crosses 3 different calendar days. So we want to think about how that works, and we need to think about the consumption patterns of this data. Do our consumers want to consume it, grouping everything together at week 5? Do they want it by day, or do they need to know, hey, this was a day game, or a night game, or a Monday night game? So that's where we have to think about, if I start passing some data as week 5 and some data as, a start time of, 10, 6, 2 o'clock, 1 o'clock, that's not going to line up. And so I need to think about what might I do with it. If I'm trying to do some sort of analysis about attendance on certain calendar days, I might want calendar day. But if I really am focused on what's the holistic data set of all the NFL teams in a given week, and I want to line that up within that same time frame, then I probably need to think about the week. So there's a couple gotchas if you do it this way. First gotcha is you have to think about how consumers are going to aggregate this data. If I take the games in my example and I say the Bengals opponent was the Ravens, that was 1 game, and the Ravens opponent was the Bengals, that was 1 game. If I add it up, that equals 2. How many games were there? 1, right? And so you have to think about that. How am I going to use this data? Because both are relevant and both have the right context for what I'm thinking about. But if I'm aggregating in ways that are not the standard pattern, I'm going to get the wrong answer. And so what we could do is we could actually add a new metric that says, game participant or game half or something like that, which would result in the appropriate summary number. And these are just little nuances within the data that you have to think about as you're structuring it. Another gotcha, and this is about use cases. Excel has a row limit, right? So if you structure data in the way that I'm talking about, you're going to have lots and lots and lots of rows, not a lot of columns. But if your users are mostly using Excel, you're going to break their use case if you have a lot of data. And so that's a real challenge that you want to consider. Here's where we get into what's an attribute and what's a metric. We talked about those start times. And I could stage those 3 parameters as a start time of which NFL week, which day, and which time. But maybe I've got a model that wants to use those times in a more standard way. And maybe I want to line them up across a season or multiple seasons. So what I might do, instead of having these as attributes that then, as a data scientist, I have to hotkey and code or something, right? I can actually structure those as metrics as well. And that starts getting us to think about how do we standardize these data sets for a much more broader set of consumption. We talked about retroactive changes. There's 2 ways to think about sending data in terms of a retroactive change. You can either send the change as is, like let's say in the example here of the football game, we had an attendance estimate of 66,000. And then maybe a day later, we figured out that actually the actual attendance was 66,254. In that case, how am I going to consume that data, right? If I consume that data before the revision came out, my model that I'm working with says 66,000. If I consume it after, I get 66,254. The question is, which one do we want and how do we want to get it? Well, if I know I have thousands of data consumers and they're pulling on this every single hour, I probably don't want to delete data from my source and re-add it as a new value. I probably want to give them the delta or the change to that data, and that way their model can sum it up. But what you need to know is you need to know, are the use cases actually using this to sum up data in this way? Right? Because what you wouldn't want is them to think that these are exclusive records and they had a second game that only had 254 people show up. Right? So that's where you really have to think about what is the consumption. All right. So I went through that really fast because I think there's a lot of room for discussion here. And by the way, I forgot to mention this. I have a lot of topics, so there's no topic that's not fair game related data if you want to talk about it. But in terms of the recommendations, if you're going to build a data exchange framework. You need to really think about the ownership, who owns the data, how often is it going to change, how do you need to best represent those changes, how is it going to be consumed, do you need to show it as a row or a column approach. You know, if you have 10 metrics and there's always 10 metrics, columns are just fine. But if you have hundreds or thousands of metrics, we created an initiative at Paycor just in the last 3 months, where in 3 months we have 120 metrics that need to be exchanged to a wide variety of systems. And so we had to use that row approach because we needed to, and our estimate is by this time, well, at the end of the year, we're gonna have 300 metrics. And so people need a way to rapidly consume them without breaking all their data engineering mechanisms. And then stability, right? So if you think about the stability of this, I'll tell you a story. So we were talking economics and econometrics earlier. How I learned how to do regression and all those things, I would go to the library, get books, write it down on paper, then go to the computer lab, type it in, right? Anybody do it that way? Long time ago. And so if you think about that, I didn't care about stability because everything I was going to do, I had to go through that process and start from scratch. So I didn't have to worry about that. I could structure it any way I want, and I did, for that matter, structure it any way I want every single time. But if I'm going to use Python, and I'm going to use a data warehouse, and I'm going to use an LLM that's going to consume all this, the results of this, then I need it to be the same way, because if I train a model, and then I try to load data that has totally different parameters and different column names and dimensions, that model's not going to work. So that's where this becomes a lot more important. So it's a fairly simplistic topic that we had today, but I wanted to do it in this way because I wanted all of you to think, especially in the context of AI, I wanted all of you to think about, hey, how you structure your data matters, where you get your data from matters, and how they're providing it to you matters. All right, with that, I'm going to open it up to questions.
Yeah. So while looking at like the metrics, what was your take on like efficiency? Because I feel like some of this stuff wasn't very efficient when you were kind of having 8 rows when you could just have 4. So what is your look on that?
So let's take a look at that. So here's the question, right? As what does this do to efficiency? And that question, to be answered correctly, depends on the consumption patterns. You may have, this is probably hard to conceptualize in terms of this particular data set, but you might want to have a data set where you might have, in this case, 4 metrics. Some people might only want 1 or 2, right? And they always want those 1 or 2, right? So what this kind of thing does is it enables you to let people pick and choose in their filtering without changing their downstream structures, how they're doing. For example, if you, in this case, you don't have much data, but you could create a points per game metric, right? And maybe you just want 2 of the pieces. But you have to think about how systems process. Does anybody know how you get charged for your licensing when you're using a cloud data warehouse model? Anybody know that? What the cost model is?
I think it depends on the cloud.
Well, yes and no. Most of them charge you for storage, which is not that much these days, and compute, which is the big deal. And when you have a simplified data set like this, it's a much, much more streamlined compute. You can use much smaller resources than if I had a bunch of rows out to the right. And so when you do something like this, and your question was efficiency, but costs are also a consideration for efficiency, right? And so something like this is going to be more cost efficient and might be easier to pull out. If you're using this in use cases with, say, Excel, or you're cobbling together CSVs, or you're custom doing it, then it's a little bit more complicated in terms of that, because what you're going to want to do is pivot this out. Now, there are pivot functions in Python and Excel and SQL and all those things, but you would have to do some manipulation work. Next question.
You talked a lot about the downstream consumption that kind of drives the use case for how people use it, but at Paycor, do you get specific in any ways of how you want your data owners to structure their data? Or is it really up case by case?
Yes, so that's a really good question, and that we could spend another hour talking about that at least, but the question is, do you kind of dictate to your consumers how they're going to structure their data? And the answer is, that's generally called in data governance terms, certified data, right? So basically you create what's called a certified data model, and that model basically says, these are the sources to create these particular calculations, whether you're talking about how do I calculate number of customers or revenue, or what markets are we in. And those are a lot of times staged as, you might think of it as a subassembly, right? They're a lot of times staged in a business intelligence framework so that people can consume them. And those are known patterns, right? But those tend to evolve with the business, and usually that's on a quarterly basis, those change over time. So it is something we know it. When we're talking about exchanging with our customers and our partners, that actually becomes a much more structured as well, because those partners now, they may be paying us for that data. Those customers may be paying us for that data service. And so not only do they need a consistent set of data, but they also demand consistent definitions and that the data doesn't change. So a lot of times what you'll see, and this is where it gets really crazy in data exchange framework, a lot of companies, what they'll do, if they want to change something, they won't change the existing data set. They will version 2 and 3 and 4. And if you're in a modern day data engineering shop where you're working on integrations, you might actually have integration frameworks, transforms in the middle or landing it, where you are pulling from all 3 of those versions of those sources, and then the burden's on you to keep it straight. And a lot of companies don't love that, right? Because that makes it very complicated, and a lot of times you get wrong answers because people make assumptions. So it is very important as you're structuring data sets. A lot of you that might be doing modeling, buying data from marketplaces and other things, you have to demand consistency there and clarity in terms of what that data is, or else you're going to get a wrong answer. And if you think about this morning's talk about all the ways that AI can go wrong, this is what's beating your AI, right? These data sources, it's not just what you're producing internally, your organization. Every one of your companies most likely has third-party data services that are used. Yeah. Go ahead.
Yeah, awesome talk. I'm thinking about, I guess, in this framework where you have kind of like the metric number column, that's great for, hey, we want to add a new metric, and that kind of flows downstream. At the same time, if you have users ingesting that data that say they're like, I don't know, iterating through metric numbers or doing something that maybe you didn't expect them to do, it could break their processes in an unexpected way. It's almost kind of forcing your downstream users to opt in to changes to the schema. How do you think about communication and like transparency and trying to make sure that your users are kind of like using your data in the way that you intend them to?
Yes, that's a very good question. So there's a few things really. And the question is, if you add a metric to this, a 1003, which maybe is something that your downstream don't anticipate, how do you manage that, right? And the answer is that this is a concept that, you know, in ERP world we call master data definitions, right? Generally, these are what you call a number range, and so a lot of times you'll have number ranges that are smart number, right? So in this case, maybe we mishmash a data set together and we say, you know, that the 1000s are for games, single games, and, you know, 2000s are for season statistics, right? Or season to date. And those are the kind of things where that has to be articulated and published, not just in documentation, but also in a translation table, right? So most of the time when you do something like this, you're going to provide an associated base table, which gives you the parameters, and you're going to, if it's a situation where you're actually monetizing or at least putting it out for broader distribution, you are going to have release notes and a regular release schedule that gives plenty of heads up before that kind of thing pops in. All right, any other questions? Yes.
I understand that this is really helpful for those who are using a BI tool, say like for instance Tableau, it's easy for filters and all that. But I don't understand why would someone pivot like the metrics? Like why would you put points like 4 as a column and points like why would someone have to do it that way? Like is there a reason?
There is, and there's a very specific AI reason I'm thinking of. Anybody want to offer a suggestion on that before I give my answer? So the question was, why would you want something in this structure, or why would you not want this structure? Why would you want something more like this structure here, where you have distinct columns and metric views?
Improve the performance.
Sorry.
It's for improving the performance.
That could be, depending on what you're doing, but I think if you think about AI feature engineering, right, a lot of times the features require you to have it in columns because of the way that the Python or other libraries work. And so you would have to structure, you would have to convert from this format to this format for certain AI use cases where you're doing feature engineering. But what's interesting is, when I say hot encoding, you guys know what I'm talking about, 1P hot encoding. Basically that's taking a bunch of values that are maybe text in nature and turning them into something like we looked at here, where the values of each of these would be a binary 1 and 0. And these are the kind of things that you could easily take into that feature engineering and then have outputs that are more standardized based on these dimensions. Additional questions?
Slightly different answer to why someone might shift.
Oh, yeah.
And it doesn't have to do with the computer. It's because at some point in the process, a human was reading it, and humans like it that way. And so, your end result in a lot, if you're going from some legacy product to an actual data system, your sources will be these tables that humans read. And that's why you see those a lot. Is just at some point a human was in the process and they wanted it that way.
Yeah, that's exactly right. I mean, and a lot of this is preference. If you work in finance, which I've worked in and out of finance my whole career, finance people like dates at the top, right? They like quarter 1, quarter 2, quarter 3, or month 1. And so they kind of would prefer this kind of format where they see all the metrics listed like that in rows, right? That's a very common use case. But if you're in, say, manufacturing or you're even in engineering looking at statistics, you tend to want to know more specificity around the statistic and then you can compare it down. So it just depends on how you're thinking about the data. Data can be structured a lot of ways, and that was one of the things I wanted all of you to think about in this session is that you need to put some thought into how to structure it, and you need to think about, just like what you're saying, what's the preference of those users?
Just to continue on that, when I think about architecture, the row-based seems to me like that might be your underlying data lake, raw data architecture, and then for these examples of a human digesting it or a Tableau digesting it, those would be individual manipulated data layers that are driven off the lake. Is that an appropriate way to think about it?
Absolutely.
Like
That's
that'd be your
exactly how you should
recommendation?
think about it.
Yeah, okay, got it.
Yeah, no, that's great.
Okay.
Getting through. Any other questions? I can talk about this all day. Yes.
One thing I see at our organization is we get some of these really, really large tables and they don't have partitions. And so we're talking insane compute. And it's just like, how does that happen? And how important is that?
Yes. So the question is about partitioning. If you get a really large table, like the one that you can't put in Excel anymore, for example. And so just to give you a little anecdote there, at Paycor we have a couple of tables that are 1 trillion rows, right?
Yeah.
That's a lot of data. And partitioning is where you kind of have the system, chunk it up so you can make it more efficient for processing, right? But some of the new cloud warehouse technologies actually have algorithms behind the scenes that do that for you, so you don't have to do all that indexing and partitioning you used to do. But it is something to consider, and the best way to figure that out, whether you're working with AWS, Google Cloud, Snowflake, or others, is really trial and error. It really depends on how they've optimized their compute to work, and we use Snowflake, and we have actually noticed that you can use a lot smaller warehouses, a lot less compute when you have lots and lots of rows but fewer columns, especially if they're numeric in nature. So one of the reasons why you want to put these numeric codes in there is that these are handled by compute engines much more efficiently, even though it might be the exact number of characters, right? And even the same, distribution and whatnot, but numbers are handled always much more efficiently by databases. Yes.
So I heard you store this data in a data warehouse in this format, right? Like when the data comes in from the source system, it may be just regular format, right? So do you pivot all of those and store it, and then when you consume it, depending on what tool and who they pivot it back?
So that's a really good question. So the question is, how do you get it into this format, right? And how do you do it from an engineering perspective? So let's talk about how this data kind of comes in. So let's look at this data set right here. So where did I get this data set? I pulled it off NFL website. And but this could be, I could pull it from some sort of archive that has this kind of format for, let's just say, 25 years, right? And it might be a lot of data. And so what you really have to do, this is where you have two mechanisms you can do it in. You can either just pull in that source data as is in an ELT format and then transform that inside your warehouse, which is what we do at Paycor. Or I could just go to that repository and I could build basically a script that would pivot this data, right? And why would you do one versus the other? And this is, does anybody know what the recommendation of all the vendors these days is of ETL versus ELT? ELT. So ELT is usually the recommendation, and the reason why is because, if I come back here, remember what I talked about in terms of what's the truth, what's correct? If you stage like for like here, there's two significant advantages you have. Number one, it's very easy to go back to source and make sure you got the right data. And if I'm looking at it this way, it's really hard for me to say, I got 28, is that what I should have gone, right? So that's the first thing. But the second thing is, my data source, a lot of times, is limited in terms of what I can get to or not very accessible. And also, I can't really run a lot of compute against it. My data target, if I know my data target is exactly what's in my source, and I've verified that, I can use this now as a proxy for the health of the source system itself. And I can run metrics on top of this data that I could take out those compute processes, which are much more expensive than something like a Salesforce, for example. And I can take that out of there, do it in the data warehouse, and then use those learnings to go back and optimize my source database. And so there is significant advantage to having this copy in a place where you can do other operations. And if you think about AI, I don't know about you all, but I get questions like, can we just take our entire CRM database and put AI on top of that? And the answer is you could, but you'd have to do something like this with every single data set that we